under fractions. Let's see, fractions. If you see these directions, you must do it exactly like I show you here. Because you could do it alternate ways, but this way they tell you. The directions say use prime factorization to reduce. And then they may give you a problem like 125 over 1,000. Like that. 125 over 1,000. And this is simply what you would do. And this gets a little awkward and long, but we have to do it here. The first thing you have to do is prime factorize both numbers. Oops. Prime factorize both. Which unfortunately means you got to come off to the side here and do 125. Now, if you were prime factorizing 125, you get your choice. Do you want to do the tree thing or do you want to do division by primes? Zachary, what would you prefer?
The tree thing.
Hard. You have to. What times what gives me 125?
14.
And if it's hard for you, maybe you should have done it the other way. But you could. $1.25 is how many quarters?
25.
So it's 25 times 5. And then 25 is 5 times 5. Okay, so this top one ended up being 5 times 5 times 5, correct? Okay. Then you also have to do 1,000. If you were breaking up 1,000, how would you do that? Brian, would you do product of primes or division by primes?
Division by primes.
You guys always pick the one opposite one I would probably do. But let's do it, division by primes. It is a big number, so cut it in half would probably be a good idea. Half of 1,000 is 500. Cut 500 in half, you get 250. Cut 250 in half, you get 125. Now, ladies and gentlemen, what I will let you do here, boys and girls and kids of all ages, we already prime factorized 125 right here. You don't really have to reinvent the whole wheel twice. In other words, you know you've got these 3 2's from right here, right? And then you know you've got 125 here. Well, 125 is this, is it not? So you could just write that down as those 3 5's. 125 prime factorized will always, always, always be 5 times 5 times 5. Are you with me so far?
Yes. Yes.
That's step number 1. Now see how long it took us to do step number 1? That's unfortunate. Step number 2 is you can cross off identical, you've done this before, top and bottom factors 1 for 1, which is what you did before. I think we even had a problem like today, right? You did problem number, what was it?
It was
Problem number 29, which just means this. I have 1 5 on the bottom, it crosses off with 1 5 on top. I have a second 5 on bottom, crosses off with the second 5 on top. I have a third 5 on bottom, above, nothing else crosses off. So step number, what are we at? 3 is to remultiply for top or bottom. Well, but you ask yourself, look, there's nothing left on top. So, what? There's nothing left on top. If there's nothing left on top, there's always a 1. Always a 1. If everything crosses off, there's always a 1 left on top. Same thing for bottom, but bottom ones don't matter. And then what is 2 times 2 times 2? 2 times 2 is 4 times 2 is 8. This is your reduced fraction of this. Now, are there other ways to do it? Yes, but if they ask you to do it by prime factorization, you have to do it that way. Got that? Now, like I said, the book is generally nice, and they will give you easy ones that have like the same factors. In other words, here's example number 2. 375 over 1,000. If you're given this problem in the book, children, we already prime factorized 1,000 and maybe you already have it in your notes. I won't make you do that whole tree thing again. You know that 1,000 is 2 times 2 times 2 times 5 times 5 times 5. How do you know that? Because we just did it up here. This was 1,000. Now we did not do 375. So 375 you're going to have to do. This is one I'd probably do product of primes with. 5 goes into 375, what? 70, wait, no. Yeah, 75 times. What times what is 75? Why can't I do 25 here? Chase?
This is not a prime
It's not a prime number, right? We're division by primes. 5 goes into 75, 15 times, and 15 is 3 times 5. So the prime factorization of 375 is 1 3 and 3 5s. And then, children, and only then can you cross cancel 1 5, 1 5, second 5, second 5, third 5, third 5. Nothing else crosses off, so you're left with a big 3 on top and a 8 on bottom. Please make sure that you remember that 2 times 2 times 2 is not 6. It's not 2 plus 2 plus 2, it's 3 times 2. Does that make any sense? Let me give you one to try, and this one won't be so bad. 48 over 400. 48 over 400. Do that one for me. Prime factorize it and then reduce it by using your product of those primes. And see what you get. Maybe, just maybe. Just maybe. Answers?
Been sent to retrieve Sophia.
Retrieve a who?
Sophia.
Hey,
She's got a point.
She got a who?
dentist appointment.
Oh. Like a dentist appointment. Did we come up with this as your prime factorization? Hopefully. 2 times 2 times 2 times 2 times 3 over 2 times 2 times 2 times 2 times 5 times 5. So far so good. And when you cross them all out, we end with that cross off, that cross off, that cross off, that crosses off. Nothing else crosses off. Don't forget you have to multiply. It's 3 over 5. In the real world, will that be the way you always do it? Probably not. But if they ask you to prime factorize, yes. Madison.
When we prime factorize using nominals changes,
Huh?
you don't want us to ever reduce.
rephrase that in the form of a question I understand.
When we factorize.
Well, if they ask you to do this, are you saying, should you take 48 over 100 and then say, oh, divide this by 2 and get that, and then prime factorize that?
No, like the end answer.
Well, you'll never, if you do this right, this answer will never be able to be reduced. That's why you're doing this, you're reducing it through doing that. Really what you're doing every time, Madison, if you really want the nuts and bolts of the whole thing, is when you did this, you really reduced this by 2. And then you reduced it by 2 again, and then you reduced it by 2 again. See, watch, 48 over 100. If I reduce it by 2, I end up with 24 over 50, right? Cut them both in half. And then I reduced them by 2 again, which gave me 12 over 25. Oh, that's right. Wait, this was 400, sorry. Cut that in half, and that should be like 200. Then you reduced it again, and that was 100, and then you cut them both in half again, and you got what? 6 over 50, and then you cut them in half. The fourth time, you end up with 3 over 25, which is where that. Does that make sense to anybody?
Somewhat.